here, right here, of course, my first life, and I know things are not going to be perfect. Of course, that's why it's going to be a first life, right? Well, it's not. It's a first life because it's the first time I'm going live, not because it's not going to be perfect. Okay, so my name is Solo Anch, and I want to know how you're doing. Of course, it's nobody. Okay, so we are going to be doing just two integrals, right? Just to test things and hopefully improve on this. So we have the integral of 2 sine x divided by sine x plus cosine of x. Good. Well, second one here has the same structure, just that here we've replaced this sin with ac, which means secant of x. Okay. Uh, well, this is not that bad. In this case, we'll just notice that if we can have, this is not that bad anyway. Okay, and integrals, you just have to keep working on examples. Right? I think I've done something like this before in one of my videos on integrals some time ago. So to do this, we'll just first of all rewrite this 2 sine x as, of course, we know it to be sine x plus sine x will give us 2 sine x, right? So we can replace this with that. So I'm going to rewrite it as sine x plus sine of x. Of course, that's 2 sine x, right? So we divide this by, the denominator stays the same, which is sine x plus the cosine of x. We put the dx over here. Okay, now the next thing we want to do is to rewrite this numerator such that we can have the denominator, that is the exact form, sine x plus cosine of x, somehow. And that's going to be by adding 0 to the numerator. And this is what we're going to do. This means now the denominator stays the same, that is sine of x plus the cosine of x, right? This is plus, not t. Good. So in the numerator, we have this original sine x here. But we want to get a cosine of x. That is, we want to write so that the numerator and denominator are the same at some point. So we're going to add cosine of x to the numerator. But we are going to subtract it because we just added something, right? Okay. This sine x is here already, so I'm just going to add the sine x that was there already. Then we've added cosine of x, so we need to subtract it. So I'm going to subtract the cosine of x we just added. Okay? And then you put the dx over here. Very nice, isn't it? So in this case, I'm going to split the integral into two. So the first part will be sine x plus cosine of x divided by sine x plus cosine of x, which is just 1. We put the dx over here. And then we're going to add it to the second integral, which is going to be the integral of this part, which is sine of x, right, minus the cosine of x divided by sine of x plus the cosine of x, and then you put the dx over here. Of course, when we integrate 1 over the x variable, we just get when we integrate 1 over the x variable, we just get x. Oh, I've noticed there are 2 people here. I hope, how are you doing? This is Solo Anch, of course, and this is my first live video. The 2 of you, I don't know if you are hearing me. I'd like to get your message, just a welcome message to you, right? You're welcome, and let's continue anyway. Okay, so when we add these two, when we take the integral of these two, right, of this, and when we evaluate this integral, well, you notice that this is sine x and this is negative cosine of x. We know that if we have the integral, okay, if we have a denominator, let's say some function of x, and the derivative of the denominator is in the numerator, then the result is just going to be natural logarithm of this denominator, which is this function of x in the denominator, right? Good. So that's what we are going to be doing over here. If you differentiate sine of x, you get positive cosine of x, not negative. If you differentiate cosine of x, you get negative sine x, not positive. So that means that we can simply just multiply this numerator by -1, so that to change the sign of those things. And we can also divide it by that -1 we multiplied it with. All right? Okay, so by so doing, by the -1, sorry, positive and negative will give us a negative sign. Then we take the integral of, well, this negative will change the sign of each of these so that we have what we wanted. So that will be positive cosine of x minus sine of x. We divide this by, of course, sine of x plus cosine of x. Okay, let me clean this. Now, of course, you notice that, keep that rule in mind away. You notice that this is x minus, right? Okay, Now the derivative of this denominator will give us the numerator simply. Don't forget the dx. The derivative of sine of x is positive cosine of x, while the derivative of positive cosine of x is negative sine x. So that means we're going to have natural logarithm of the denominator, which we can write it as sine of x plus cosine of x. Okay, and we are doing indefinite integral, so we add an arbitrary constant to this. And you take note that I'm using an absolute value here for my sine x plus cosine of x. That is just to extend the domain of this natural logarithm function. That is to be sure, to ensure that this solution, this antiderivative will exist. Okay, even when the sum of these two is not positive. Okay, and if you add this two and you get 0, the result does not exist, so to say. But this is an antiderivative, which is a function that we can differentiate to get that. But hopefully that works. Okay, let's look at this part. So what we did here was to rewrite the 2 sine x as sine x plus sine x. Well, should we rewrite this as secant x plus secant x? What do you think? Will it work that way? Let's see. Oh, okay. What do you think? Will it work that way? Well, secant x plus secant x. Well, you can go ahead and do that and maybe put your comment. Okay, let's see what you got. But I'm not going to do that. Rather, I'm going to divide numerator and denominator by something. Okay, so that I can get something good out of it. So let's say we divide numerator and denominator by cosine of x. So we're going to multiply the numerator by 1 over cosine of x, then multiply the denominator by the same thing, 1 over cosine of x. So when we do that, we are going to get, well, this is going to be 2. Notice that secant of x on its own is 1 over cosine of x. So when you multiply 1 over cosine of x by 1 over cosine of x, you have 1 over the square of cosine x in the numerator. Then we divide it by, well, this will come over here. Sine x divided by cosine of x will give us the tangent of x. We add it with cosine of x divided by cosine of x, we're going to get 1. Okay, but of course 1 over cosine of x is something as secant of x. So the square of cosine will give us the square of secant. That will be 2 square of secant x divided by 1 plus the tangent of x. This is tangent of x, right? We put the dx over here. So here we're going to make a substitution. We keep in mind that the derivative of the denominator will give us the numerator, except for the 2. That is, derivative of 1 plus tangent of x will be secant square of x. Okay, and by that rule, which I wrote down here, that if we take the integral of some function of x, okay, some function of x, such that when we differentiate this function, we get its numerator, the result will just be the natural logarithm of the denominator. Good. So using that, if we make a substitution, we say let u be 1 plus the tangent of x. We notice that the derivative of that is going to be secant square of x dx. Okay, so by so doing, we're going to have 2 is here. Now, secant square of x dx, we can replace it with du, right? That's secant square of x dx. We divide this by 1 plus tangent of x. Of course, we called it 1 plus tangent, we called it u. Good. So this is going to be 2 times, well, du divided by u, the integral of that will give us natural logarithm of u. And u here, we called it 1 plus tangent of x. So that's natural logarithm of 1 plus tangent of x. Good. And that's all, because we're done evaluating the integral. So we can just add an arbitrary constant. And this right here is the antiderivative of this function. Why this one is for that. Okay, that was just going to be a brief video, right? Just a brief live, since it's the first one I'm doing. And well, for now, just one person that we have here. Can I view who? Well, I cannot, but whoever, thanks for watching, and we'll continue from our next video, right? Thank you, and I'll see you in our next video. Bye. Please don't forget to share the video and subscribe. How do I end this? Okay.